Hello, everybody. I hope you are enjoying your off day so far. So this is the intro to matrices. And so we're going to talk about how to add and subtract matrices, and multiply matrices today. And then, so we'll talk about what a matrix is, and then we'll talk about how to add and subtract. Super easy. Multiply, just a little bit more difficult. And then you'll have a assignment to work on. And then when y'all come back in person, we can go over any questions that you might have. So first of all, what is a matrix? There is a movie, right, called The Matrix. It's getting kind of old now, but a matrix is an array of numbers. And you can think about these as kind of like a bunch of data put in to an organized fashion, all right? And so matrices are really common when you're getting into electronical-based stuff, computer programming, those types of things, because they can hold a lot of data in a short amount of time. And so if you look down here, these are matrices. And what we're going to talk about in this class are just very basic intro to matrices. And then if you go on and study some upper level mathematics, or you get into some engineering and things like that, you're probably going to see matrices in a lot more detail. So we're just going to talk about the surface, essentially, kind of introduce you to them, but just know there's a lot more that goes into these. Each matrix has what we call rows and columns. And so these matrices will be identified based off of their rows and their columns, all right? Rows go this direction, columns go up and down, all right? So think about like a column in a building, right, up and down, and then rows are your left to right. Each individual number in a matrix is what we call an entry into that matrix. And they're used in objects like computers and cell phones, pretty much anything that pretty much anything that has to do with compiling data, like putting a lot of data. So like video games and things like that, right? Those all have a lot of matrices used because they can process numerical data pretty quickly. All right, so anytime you want to talk about a matrix, we refer to it by its dimensions. Its dimensions are the rows and the columns. And whenever we're going to refer to matrices, it's always the number of rows by the number of columns. So if you look at this matrix here, this has 2 rows and 2 columns. So we call this a 2 by 2 matrix. This matrix here, 2 rows, 2 columns. So once again, that is a 2 by 2 matrix. This one's also 2 by 2 and 2 by 2. Here's another 2 by 2. This one is 2 rows by 1 column, so we call that a 2 by 1. Over here, 2 rows, 3 columns, so it's a 2 by 3. And this one is 3 rows, 2 columns, so a 3 by 2. All right, so kind of just how you're going to refer to a matrix, you can call them like, hey, I'm talking about the 2 by 3 matrix or the 3 by 2 matrix. And then you can assign like letters for names as well. We could call matrix A, matrix B, C, whatever kind of letter we wanted to use. All right, the dimensions are needed to perform operations like adding, subtracting, multiplying. There is no such thing as matrix division, although you can divide because dividing is the reciprocal or the inverse operation of multiplication, right? So if you can multiply something, technically you should be able to divide it. It just might look different than normal division. All right, and there are some special matrices that exist. They're what we refer to as identity matrices. And what they're going to look like is they're going to be square in terms of the fact that there'll be 2 by 2s or 3 by 3s or 4 by 4s, square as in the same number of rows and columns. And when you have a square matrix, it can be an identity matrix if the diagonals are 1. The diagonal is all 1. So if there was a 3 by 3, you'd have another 1 here. 4 by 4 would be another 1. Just the whole diagonal is 1. And every single other number in the matrix is 0. And so we're going to use that identity matrix along the way to kind of help us out. By the way, an identity is equivalent to the number 1. So, like, for example, if you do 10 times 1, you're just going to get 10. Or if you do 10 divided by 1, you're just going to get 10, right? It doesn't actually change the value. And so this matrix here is not going to change the value of any matrices that you're working with as well. So this is like the one version. All right, so let's go ahead and get into some adding and subtracting. So whenever you go to add or subtract, the matrices must have the same dimensions. Remember, your dimensions are your rows and columns, rows by columns. They have to match. If they don't match, you may not add or subtract. So for example, these match, it's a 2 by 2, so you can do this operation. These also match, it's a 2 by 2 and a 2 by 2, so you can go ahead and subtract here. These ones do not match. You have a 2 by 2 and a 2 by 1, so this one can't be done. It is not possible to add those matrices together. Same thing here. These matrices are not the same dimensions. Yeah, it's a 2 by 3 and a 3 by 2, but this one's reversed. So once again, this cannot be done. All right, so let's talk about the ones that can be done, exactly what that will look like. So I'm going to zoom in. And matrix addition and subtraction is pretty easy. What this is 4 addition problems. You're going to do 1 plus, and then the number in the same location, 4. It's in the first row in the first column, so they're in the exact same spots. And that answer will go in the first row of the first column. So 1 plus 4 is 5. And then you're going to repeat. So we have the second number here in both the first rows. So 3 plus 7 is 10. And then you can keep on going. You'll have 5 and 3, and 5 plus 3 is 8. So that number will go first in that spot. And then last but not least, 2 plus 1, and 2 plus 1 is 3. And so here's your matrix. And each location, the first row, first column came from the first row, first column, and both matrices being added, and so on and so forth. So it's whatever spot this one's in plus the same location, and it goes in the same spot. All right. Subtraction, literally the exact same thing, except when you go to subtract, you do minus instead of add. All right. So in this matrix, it'll be 4 minus 1, which is 3, 9 minus 0, which is 9, 1 minus 0, which is 1, and 3 minus 1, which is 2. So simple enough. By the way, this is the identity matrix. The reason this one changed and is no longer the same, because we said, hey, the identity matrix is the form of 1, right? Is because if you subtract 1, you actually change the number, right? So like 10 minus 1 changes the number, or 10 plus 1 changes the number. So this is really more helpful, this identity, if you're multiplying or this idea of dividing that we're going to talk about, all right? Multiplying or dividing by 1 doesn't change it, but adding and subtracting by 1 does change it, so. All right, and then to sum up adding and subtracting, because it really is that easy, I just have a story problem for you. So let's say you like to read, and in June, July, and August, you read fiction and nonfiction books and magazines, both in paper copies and online. You keep track of everything by the month, and this is how the data looks. So you can see here's June, July, August, how many you read paper copies, how many you read online of each type going this way, and that data is organized. So the question says, how many of each type of book/magazine did you read? And so right now, this is just in a table, but you can think of it as being in a matrix. So this first matrix has 3 rows for the 3 different types. It has 2 columns for the 2 different ways you could have read this paper online. And so those 6 numbers can be put into a 3 by 2 matrix. Now, each month would have its own matrix. And each location in the matrix is talking about the same value. So the first number in the first row and column is talking about fiction paper, fiction paper copy, fiction paper copy. So if you add those 3 up, it will tell you how many fiction books you read in paper copies. And so what this is just going to be an addition problem, right? So I'm going to put plus here, and you're just adding these 3 matrices together to get a final matrix that has those 6 values of each kind and in each way it was delivered. All right, so we'll have 2 plus 3 plus 1 So that's 6. 4 plus 2 plus 3, that is 9. 3 plus 1 plus 2, that's 6 again. 1 plus 1 plus 3 is 5. 4 plus 5 plus 4, so 13. And 5 plus 3 plus 6, 11, 14. And so now you know, if I said, how many online magazines did you read? Well, online magazines is this bottom number in the corner, the third row, second column. So you go to your third row, second column, and between the 3 months, you read 14 of them. And yes, I'm aware, like, Miss Bird, couldn't we literally have just added them together? Well, that is what we did. We just put them in matrix form in order to add them together. All right, so up next, we're going to talk about the operation of multiplying. This is a little bit trickier, and so a little bit more in depth in terms of than the adding and subtracting. So this one might take us a little bit longer to work our way through. So when you go to multiply matrices, they do not have to have the same dimensions. In fact, there's a different condition that has to happen, all right? So if they're the same dimensions, they may multiply, they may not multiply, but different condition. And what the different condition is that the number of columns in the first matrix has to equal the number of rows in the second matrix. All right, and first matrix is literally the one that's first. Second matrix is the one that is second. All right, and if they do not match the number of columns, I spelled that wrong, sorry, and the number of rows in the second matrix, then you cannot multiply. So let's go ahead and we'll do some examples so you can see. So what's the dimensions of this matrix, and then what's the dimensions of this? And it's actually helpful if you write them up here. So this is 1 row by 2 columns. So this is a 1 by 2. This one is 2 rows by 1 column, so that is a 2 by 1. The matrix can be multiplied if these two numbers on the inside match. So when we say the number of columns in the first matrix match the number of rows in the second, those two numbers have to match. And if they match, then you can multiply. Also, if they match, then the other two numbers will give us the dimensions of our solution. So our solution matrix is just a 1 by 1 matrix, and it just will have one number in there. And so you might be thinking, well, there's 4 numbers. How do we go from 4 numbers to 1 number? And I'm going to show you. So when you go to multiply, it's rows by columns. So this row gets multiplied with this column. And when you do rows by columns, it's the first number in the row and the first number in the column, multiply those two together. So 6 times 4 is 24. Then it's the second number in the row by the second number in the column. So 5 times 3 is 15. And then to finish this multiplication, you actually add those two numbers together. So our solution is one matrix. It's a 1 by 1. There's one number, and it is the number 39. So multiply matrix is a little bit different. All right, so let's take a look at this one. This is a 2 rows by 2 columns, so this is a 2 by 2. 2 rows by 2 columns, so that is also a 2 by 2. And the inside here matches, so that means that we can multiply, and our solution will be a 2 by 2 matrix. So this solution will have 4 numbers a part of it. And the process here is the same. It is the row by the column. So the row, here's your first row. We're going to multiply by the first column. So 2 times 3 is 6. 1 times 8 is 8. Add them together, we get 14. So the first row, first column, the first spot there, first row, first column is the number 14 from 6 plus 8. And then to get the other numbers, you're going to continue. You can do the first row now, and instead of the first column, you can multiply by the second column. So you're going to kind of repeat, but use a different column. So 2 times 2 is 4. 1 times 1 is 1. Add those together, and we get the number 5. And this was first row, second column. So your answer goes first row, second column. So there's a 5 right there. And then you repeat the process, but now instead of using the first row, you can use the second row. So second row, first column, 4 times 3 is 12, 2 times 8 is 16. Add them together, we have 28. So that went in the first or second row, first column. So in my matrix, second row, first column, so it goes right there. And then last but not least, second row, second column. So 4 times 2 is 8. 2 times 1 is 2. Add them together, we get 10. So when you multiply a 2 by 2 matrix, you ended up with a 2 by 2 matrix. Or sorry, I guess when you multiply 2 by 2 by 2 by 2, you get a 2 by 2. That's a lot of 2s. But it's always this process of rows times columns, rows times columns. All right, so let's check out this one. First matrix is a 2 by 2, right? Rows, columns. Next one, 3 rows, 2 columns. And these two numbers in the middle do not match. So guess what? We can't multiply. And here's where the problem is going to run into. If you take this row and multiply it by the first column, you only have 2 numbers to multiply by 3 numbers. How does that work? Because if you do the first one times the first one, second times the second, what does the third one get multiplied by? Does it get multiplied by this, different number? And so that's why we can't multiply there. All right. Next one, we have 2 rows, 3 columns. And then this one's 3 rows and 2 columns. So these match, which means that we can multiply, and our solution is a 2 by 2 matrix. The 2 numbers on the outside, 2 by 2. All right, so we're going to do row times column. So first row, first column. So now we have 3 things to multiply by 3 things. So it'll be 3, 6, and 9, right? First ones, second ones, third ones. Add them all up. That'll give us an 18 in that first spot. And then do the same row, but now by the second column. So now we'll have 2, 3, and 27. So that's what, 32. So that next number is 32. And then you do the same thing, but instead of the first row, move on to the second row. So second row, first column, we'll have 9, 4, and 5. So that'll be another 18. And then second row, second column now is 6, 2, and 15. And so what that'll be 23. Multiplying matrices. All right. Go ahead and hit pause in the video. Try the next 2 and see what you come up with. I know they're 3 by 3s, but it's still just rows by columns, right? Rows by columns, rows by columns. And then when you're ready, hit play, and I will give you the solutions. All right, here we go. Here will be the solutions to the last 2. So hopefully you gave them a shot so you can kind of check, see how you did. So here's this one, just the solutions. And so you can check if you have any numbers right, then you did that multiplication right. If you have a number wrong, that means you just did one of your sets of multiplications wrong. So what I'm saying is here, if you did not get 12, then when you multiplied the second row and the third column together, wherever you did that at the second row and the third column, then you made a mistake on just that one spot. You didn't make a mistake on all of them unless all your numbers are wrong. So just be careful. Just because one number is wrong does not mean that you messed the rest of it up. All right, and then the last one, this right here, this 3 by 3 matrix was a special one. It was 1s on the diagonal. Everything else was 0. And this is just like timesing by the number 1. Sorry, that looks kind of confusing. It's just like multiplying by 1. So if you take a matrix and multiply by 1, you haven't actually changed your matrix, right? So this one you could have gotten away with not actually done any of the multiplication and just recognize the identity and just be like, hey, that won't change. That matrix will stay exactly the same. All right, and last but not least, here is a story problem application of multiplication. So it says 3 students want to calculate their grade for math class. We are given their averages and also know from the syllabus that tests are worth 40%, projects 15, homework 25, and quizzes are worth 20. So what are the final grades for the 3 girls? And so you have their individual scores, right? Each row represents a person. Each column represents a type of grade, like the test, projects, homework. So you can think about this as being a 3 by 4 matrix. So what we can do is, because if you want to figure out the overall grade for one person, you do 90% times 40, and then 100 times 15%, and then 89 times 25%, and 80 times 20%, and then you add all those numbers up, which is matrix multiplication. So we're going to create a second matrix over here that has to be 4 by something. Why does it have to be 4? Because those two numbers have to match. So it has to have 4 rows, 1, 2, 3, 4, and it'll be just one column. And in here, you're going to put the percents. So 40%, so 0.4, 15%, 0.15, 25%, 0.25, and 20%, which is 0.2. And you just do row times the column, add it together, row times the column, add them together, row times the column, add them together, and your answer will be a 3 by 1 matrix. 3 by 1, right? What's left over? And so it will give you one score, one number for each of the 3 girls. The first line will be Alexandra, the second one, Shauna, so on and so forth, all right? And so this might be a good one to use your calculator for, so you can just bust out a calculator. Sorry. 92 times 0.4 plus 100 times 0.15 plus 89 times 0.25 plus 80 times 0.2. So the first girl would be a 90.05. And then if you're using one of my calculators, you can just go up and change one of those numbers. If you're using one at home, just retype it in, right? Just make sure you're changing the right numbers. 85, 72. So then the next one, 76.55. And then the last overall score will be 86.55. So in Infinite Campus, you can kind of recognize that on Infinite Campus, they're using a bunch of matrices to calculate grades. So kind of just a nice little application there of what in the world matrix multiplying is even useful for. All right, so your assignment is, if you go to page 5, sorry, I'll zoom out. If you go to page 5 in your packet, so page 5, this is just adding and subtracting matrices. That should take you, maybe 5 minutes. Like, it should be super fast. Remember, check the dimensions, and if the dimensions don't work, then you're done, right? By the way, some of these have variables. If this one, you're looking at this one, it says r minus 3r, then r minus 3r is technically 2r, right? You're just adding and subtracting, combining like terms, but things are now in matrix form, all right? All right, if it has a number in the front like this, that is just what we call a scale factor. So add these two matrices together, and then every single number in your matrix gets multiplied by -2. All right, and then continuing on, there's page 6, and then into multiplying matrices, that's going to be on page 7 and page 8. So it might seem like a lot. It's 32, well, I lied. It's 38 problems, but the adding and subtracting ones go super fast. So the multiplying will take you more time. However, remember, not all of these will have solutions. Some of them just can't be done. So always be on the lookout of identifying what can and cannot be done. Just because there's 16 multiple choice questions or multiplying questions doesn't mean that all 16 can be done, okay? So just be on the lookout for those as well. Let me know if you have any questions. And I hope you have a good rest of your day.